this so that 7th period can have it. If I can have your attention, you of course have your exams in front of you, and I'd like for you to do a couple of things. The first thing is I would like for you to go through and add up your total points to make sure that the total adds up to the number, the smaller number that is at the top of your page, your front page there. So for example, this paper has 29.5, so I'm going to go through and just make sure that the points add up to the 29.5 here.
Was there a curve on this? You just
Yeah, I did a standard, my standard midterm exam curve is plus 10. I would say that these exam grades were lower than I wanted them to be. There were some ways in which I didn't enjoy grading them, I'll tell you that. But I like to see you guys do well, and you like to see it. So what we're going to be talking about today are some things that need to happen in order for you guys to be able to do well. Catherine, if you would mind hitting the door, that'd be great. Okay. All of you have added up your points at this time. The next thing that I'd like for you to do is to turn your test over, and on the back of your test, I'd like you to respond to some questions here. I'm not going to be looking at your answers. These are just for you, and I want to ask you some questions. First question. What did you do to prepare for the exam? How effective was it? Now, how effective was it is not necessarily based on just the numerical grade that you got, right? So if you had been running a 70% throughout the year and you got an 80%, then whatever it was that you did was somewhat effective as far as studying goes. Likewise, if you've been running a 90% throughout the year and you got an 80%, then you'd say probably not very effective. So there it is. Yes, sir.
you gave me 2 extra marks on that though.
Okay, thank you. Right after class, show me, and we'll figure out what to do. Thanks. Second question. Which topics do you have questions about?
This isn't going to do anything to change our grade, is it?
No. A grade's a grade. In 5 years, no one will ask you, what did you get in high school physics? That's just not a question people go around asking each other. I lost their attention.
Oh, you're still, oh, sorry.
Yeah.
Sorry.
Yeah.
A little frustrated.
Sure. Nobody's going to ask me in 5 years what grade you got in high school physics. What people are going to care about are really two things. One, they're going to care if you actually know some physics, right? So you don't. The main benefit of knowing physics is that you kind of understand the world around you, so that you can do smart things and not do stupid things. So things like the stuff that we've done with friction help explain why you don't want your brakes to lock and why you don't want to slide when you're in the snow, right? If you can keep rolling, you're doing better than if you're sliding around. Because you have higher coefficient of friction and you have control. I lost your attention again. Go, Heidi.
Yo.
I'm sorry. I'm sorry. Okay. I'm sorry.
But the other thing is, and this is for everyone, is attention to detail. What I saw in a lot of this is what I'd call lack of attention to detail or situational awareness. And I'll go over a couple of those things. So those are the things that we care about. Those are the things we want to be focused on learning. So if you got lower than you wanted here, don't despair. We can work on doing better. But the main thing that I want you to carry away from this is an indication that you need to be doing some things differently than you are. Okay? Okay, good. All right. Now, who has some things that they'd like to share that they did that were effective for preparing for the exam? Did anybody do something that they're really glad they did?
I studied using it.
You studied using the packet. Cool. All right. I'm glad that was helpful. Good.
I went through old tests and researched the ones that I got wrong. So I know.
Yeah. Good, good. Okay, good. What else? Something you did that you're really glad that you did. Yes, ma'am. Ah, you made an equation sheet. Good for you. Tell me why that was helpful for you, because you couldn't bring it into the test, right? But what did it do for you? It helps you remember them? Mm-hmm. Did you learn anything doing it? Yeah. Mm-hmm. Yeah. What's the O word that describes what you did there? You took material and did what with it?
Organized.
She organized it. That's exactly right. Guys, this is a high school lesson to learn. And that is that one of the key parts about learning is taking the material that you have and organizing it for yourself. I can do that for you, but you won't actually learn it unless you do it for yourself. I cannot stress.
Mr. Hagel, how much did this cost for our semester again?
So it's 20% on your semester grade, and you can do a weighted average there. Yes, sir.
I did the same thing too. I went through each chapter and looked at the equations and that told me what I needed to know.
Okay. Okay. Yep. So you got a mental equation sheet going on. Yep. And depending upon how you learn best, by seeing or by doing or by hearing or whatever. Yep. Good. I hesitate to do this, maybe I should. Does anybody have anything that they would like to share that they would recommend not doing for future use? Was anything a real waste of time that you would recommend not doing? Okay, fair enough. That's kind of hard to do. There. All right. Next thing. Which topics do you have questions about? Let's throw them out there. Yeah.
I had trouble with rotational motion.
Yeah.
And also that tension problem that was just horrible.
Yes, that was a surprise to me. In some ways, the rotational motion was not a surprise because it was the last thing we did, and we had snow days, we had videos, and said to myself, I bet people didn't watch the videos, or whatever. I was not surprised by this. I was a little disappointed. The courses problem, that one was surprising to me. I expected the average score to be somewhere around 2 to 3 out of 4, and the average score honestly was around 1 out of 4. Yes?
I had a question about something that wasn't on. So I'm still confused about center of.
Okay.
I never was reading it.
That's going to be one of the first things we do with our iPad.
Oh, should we find that app like now?
Mm-hmm.
Okay.
Yep.
I should get
Yes.
attention.
Mm-hmm. Yep. Good. Any other topics that are troubling to you? Yes.
I had trouble dealing with the diff. Because I calculated work in one, and I think I should use the work in four. Got it.
Working. Yep. Good. Anything else? If I were, in my mind, if I were to hit the 3 things that were important, I would get it. Okay. There's one more thing that I want to add to this that is really crucial. The front page was intended to be easy points. I went through in my mind and I said, what are the things that I have said in class at least 5 times? Let me ask a question on that. So I expected to be able to say, which way does gravity pull? And I expected all of you to be able to say, straight down, because I've said that like a bazillion times, right? I really had people tell me, to the center. So I drew a donut on their paper and I said, this is a donut. Does gravity pull through the center of the center of the donut? Of course, the answer is no. Right? So those questions were kind of surprising to me, and I thought through, well, why didn't that stick, right? Those things that I've been saying in class, why didn't they stick? Thoughts, yeah.
Well, it's out. I'm starting right here.
I hate it when that happens.
Yeah, I do. Okay. For on the first page, when it asks you if v is measured in centimeters per hour and m is measured in grams, and all the units of the expression at m squared v, what is that?
So here's our expression, right? And m is measured in grams, so if I directly plop in the units of grams in there, and if I directly plop in the grams of centimeters per hour, right here, then I get these units, and we're done.
Oh.
And if I simplify that, which I really probably should, then I get these units right here. I was really just checking to see if you knew how to put in units into an expression.
Wait, so we always put it in.
Some did, some did not, yeah. Yes, ma'am. Not necessarily, no. The word normal means perpendicular. The normal force is perpendicular to the surface. Perpendicular to the surface. Let's actually.
Hi, pardon the interruption. Do you have Charlie Tibbles?
I do.
Send him down for an early dismissal, please.
All
Bye,
right,
Charlie. Have a good day.
Yes.
What's
What do you want me to do? What's that? Oh, you can. Yeah.
Oh, I have another question.
Nicole's in.
What's shape does it have? Is it straight?
Yeah. Let me actually walk through all. First page still?
Me? Yes.
Yeah.
First page.
I'm going to go through them all.
Oh, okay.
Yep.
All right, go for it.
Hey, now, most of you got this right, even if you couldn't spell it. A force directed toward the center of a circular path is called a centripetal force. Which way does a normal force point? Perpendicular to the surface. The word normal means perpendicular to. If v is measured in centimeters per hour and m is measured in grams, then what will the units of the expression be? As we said here, the units of the expression work out to be grams, centimeters squared per hour squared. If an object is traveling with constant velocity, what shape does its path take? So we think constant velocity, it means constant speed and constant direction. Everybody take your finger and make it go with constant speed and constant direction. What shape is your finger tracing out? A straight line. That's exactly right. So in many of these cases, you had to take what you knew and simply work that out a little bit. Think it through a little bit. Yes?
So did you exactly say straight line or straight line?
Either one I would accept. It depends upon whether time starts at 0 or negative infinity. Right? What is... Okay, so this one kind of... here I am grading your exams at 1 a.m. And, you know, you sort of get set off by things. What is the smallest value that an object's speed can be? What word describes the motion of the particle in that case? Most of you got this. What's the smallest value that the speed can be? 0. And in that case, the object is at rest or stopped. I took either of those. Now take just a moment, i.e., and flip to problem number 3. Part 1. Find the speed of the squirrel at t equals 0.7 and t equals 1.8 seconds. More people than not told me that the speed at 1.8 was -2 meters per second.
I figured that out.
Come back to page 1 again. What is the smallest value that an object's speed can be? No, it's positive 2, because the speed does not have direction associated.
I had to circle speed.
Yeah.
Doing it.
Yeah.
Kind of tricky.
Okay, if an object moving in a straight line is slowing down, what does this mean about its acceleration and velocity? This was the most difficult one on this page. It means that the acceleration and velocity have opposite signs. That is the only way, really, that you can express it. You could say acceleration and velocity are in different directions. That could work. But I had a lot of people tell me that that means the acceleration is negative, and that is false. It is not the case that slowing down means negative accelerations. It means that the acceleration and velocity have opposite signs. Gravity always pulls everything on the planet straight down. Gravity always pulls straight down. Yep. What is the difference between static and kinetic frictional forces? I got some different answers on this, but I'm looking for definition. What is the difference between these two in terms of what they are? A static frictional force is a force operating on an object that is not sliding. And a kinetic frictional force is operating on an object that is sliding. What is a totally elastic collision? It is a collision in which what?
Kinetic and momentum energy is considered.
Kinetic energy is conserved. Momentum is not energy. Kinetic energy is conserved, right? A lot of people tell me it's a collision in which objects bounce off each other, and that's false. Not all bouncing collisions are totally elastic. Any questions on that first page? Okay.
If you said they didn't stick together at all, that would mean that they...
That does not mean that energy is conserved. Okay. Now. What needed to happen in order to do better on this front page? Because I'll be honest, I was expecting a lot of 7s, 8s, and 9s on this page, and there were a lot of 4s, 5s, and 6s on this page. Yeah.
I think one thing is, I think your vision of basic questions are different from our view of.
Yep.
I mean, like that's completely fine, but like, I just think like
I
some of
agree
these
with you.
questions are not like basic things that we would like. There's something that you have the knowledge of, it's hard to like put it into words and like.
Yes. Yeah. I think you've articulated that really well. Does everybody agree with what she's saying? Right? of asking questions. To my mind, they're basic questions. To your mind, they're not as basic questions, and it's hard to put it into words. And you captured it right there with that word words.
Extra credit.
No, brownie points. Thank you. Yeah.
I agree with the words part, because I probably spent more time trying to figure out what the smallest value of object speed can be than I did on any other problem on this entire midterm. Because I knew it, but I couldn't figure out how to say it. And it just like, but it took me a long time to figure out what I
To make
needed.
that simple. Yeah, that's exactly right. Good. That's right. The issue is words. I'm going to let you a little bit in on my mental life. I think of teaching as a matter of, well, I call it fusing horizons. It's a term I borrowed. But here is standard physics. I have a decent understanding of standard physics, right? And I'm taking you guys, and you haven't had physics before, so you're starting over here, and you've got this other horizon, this set of stuff that you know how to do. And my job is to reach out and kind of drag you into this world a little bit, right? So that the vocabulary is familiar, so that the thought patterns are familiar. We'll put beginning student right here. And one of the things that I do in order to do that is to use, as much as I can, standard vocabulary. And what I find with students is that when I use standard vocabulary, maybe normal force or some other vocabulary term, students often want to take and put it into their own words. And every time you do that, what you're doing is you're pulling back from this world of standard physics. You're putting yourself a little further away when you take and you reword stuff. So the question is, what can you do to be a little bit more immersed here? And one of the things that I do to try to make that happen is I try to get you to read your textbook. And reading your textbook is crucial because it not only reinforces what you've learned, but it also uses the same language that I've been using in the classroom to describe these things. And you start to see, as you read, oh, this is how it's described. This is what it means. You understand what I'm saying there? So the reading component of your assignment, which many of you have been treating as an optional kind of like, optional. It is not actually optional. It's really crucial because what it does is it immerses you into that world of physics so that you now are seeing that not just Mr. Hagel, but other people call this a vector as well. Yeah.
I just wanted to say that sometimes the book is really hard to understand.
Yes.
Just when you're reading it, it feels like you can easily get lost and you don't know what the book's doing.
Yes, I agree. I totally agree with that. That is a normal experience. So there, we have two things we can do with that. We can say the book is really hard to understand, so forget about it. Or the book is really hard to understand, so let me learn how to understand it. Which one of those has a future? Good point. Which one of those has a future that you want to live in? Definitely learning how to understand hard things. Because here's the sad truth about college. Here's what college classes look like. You have a reading assignment that is preparatory for college, for your class. You walk into your lecture. You get a total of 30 lectures. Like we're in school for 180 days, we get 180 lectures here. You get 30 total lectures for the same amount of material that you have for a high school course. That's it. Everything else is done based on reading. Dang. Now you understand why I assign you reading. Now you understand why Mrs. Durant gives you this many books. Now you understand why it is so important for you to learn how to read hard stuff. It really is. So, one of the things that I'm going to have you do all this week, so Wednesday, Thursday, Friday, tonight your assignment is going to go back and read certain sections out of your book. We're going to start with the forces one. Okay? And having read those sections, the next thing that you're going to do is you are going to choose 4 problems out of ones that I've selected for you to work. Now, why am I giving you the choice? I'm giving you the choice because once you've done that, you'll be able to say, oh, these problems are easy for me, these problems are harder for me. And you'll be able to choose ones that maybe you could start with one that's easy for you. That would make sense to get back into the flow of how to do force problems. And then you can choose ones that actually challenge you. And when you come in tomorrow, all that we're going to do tomorrow is I'm going to ask you if you have questions about the reading and if you have questions about the homework problems that you worked. We're going to talk about those as a class. Does that make sense? Because this component of reading, I'll be honest, it hasn't been happening, and I know it hasn't been happening. Am I right?
Yeah.
I mean, how many of you would say that you have read 50% or more of the reading assignments that have been sent?
I read when I don't understand.
Yeah.
So as an alternative thing, yeah. I would like for you to do the reading faithfully, because sometimes I can't cover everything, and because sometimes there is an important perspective to be had. So even if you understand it, you can understand it at a deeper or better level by doing the reading. So reading, and then you're going to choose 4 problems, and I recommend 1 easy, 3 challenging, on whatever level is challenging to you. And do those. Having done that, here's the next thing. Don't let this midterm beat you. Come back to the force problem, which is that tension problem on, it's number 5. Come back to that tension problem, fix it. Now, I'll move you in the right direction here for this. What one thing should have showed up on every person's paper for that tension problem? A free body diagram. Guys, I gave a point for just having a free body diagram. Which means that if you didn't get that point, you either didn't do a free body diagram, I had a lot of those, or you did it wrong, I had a lot of those. And you want to, here's where the book is helpful to you. The book shows you, here's how to do it right. Okay? You're going to do the same thing for work energy, and you're going to do the same thing for rotational motion on Thursday and on Friday. Okay? Questions or comments? Good. I would like to, since we have a little bit of time, I'd like to take a look at the Ironman problem, which is number 6. There were 2 ways to do the first part, and both of them got full credit. However, I was hoping that you guys would use work and energy, or energy accounting, since you all have become certified at it, in order to solve this problem. So I'm going to mention that you certainly could use this equation of motion in order to solve the problem, and that's fine. However, if we take a look at Iron Man here, draw a picture of the situation. Here he is. Iron Man looks like a sphere. And now he's going to drop all the way down to the bottom. There he is. And in our first iteration of this problem, he's falling without air resistance. So we're going to find his speed here. So at the top, what is his potential energy due to what force? What force is giving him potential? Gravity. What is his potential energy due to gravity? It's going to be mgh Here, I'm told by the directions to use 9.80. And so I do that. That's 150 kilograms times 9.80 meters per second squared times a height of 50 meters. And that kind of intruded. Let's move our chart a little bit. There we go. Okay. So 150 kilograms. And when we add up all those numbers, what does that come out to be? Somebody did this version of it. Did you guess? How much energy is delivered by gravity here? Did nobody use conservation of energy? Oh, you cancel out the masses. Oh, that makes sense. All right. So, okay, fair enough. Let me keep going then. So we have 1/2 v squared here with the velocity unknown. So I have then total energy here equals total energy here, or mgh equals 1/2 mv squared.
Teachers, pardon the interruption. Any teacher that is able to please stay after until at least 2:15 that is free to come outside. We need help with afternoon pickup. Anybody who could come out and help out, it would be really great. If you could come out and join Mr. Frierson at 2 o'clock to assist with this pickup. Thank you.
And so we get v is equal to 31.3 meters per second. Okay, now in part 2, realizing his danger, Mr. Stark activates his soft landing jetpack, which exerts a force directly upward, whose values are shown in the graph below. The maximum force is 2.8 times 10 to the third newtons. How much total work does the force do on Mr. Stark? Now, work is certainly area under the curve. And since we have a 50-meter drop, and we have a 2,800 Newton maximum force, then the area is 1/2 base times height. It's 50 meters, which comes out to 70,000 Newton meters. But now we say to ourselves, is this jetpack speeding him up or is it slowing him down? It's definitely slowing him down. Why? Which way is he moving under the influence? He's moving downwards. Which way is the force pointing? It's pointing upwards, the opposite direction of his motion, and therefore the work that is done on him will be negative, so that the net work is negative 70,000 Newton meters. I had very few students who got the correct sign on that work, and it's important for the next part. Yes?
What if you had your velocity as negative?
The work, even if the velocity is negative, he's going down, the work done is still negative on him because the work done changes his speed, not his velocity. So if you say down is negative, then the force is positive and the displacement is negative. When you multiply those, you're going to get negative work done. So the negative is actually invariant on this. Now, considering the force of gravity and the jetpack together, what will Mr. Stark's speed be when he hits the ground? And here, a lot of people fall apart. Think about this question. What does this question set you up to use? Nope. This question does not set you up to use sum of forces, which is called the work equals change in kinetic energy is called the work energy theorem. That's absolutely it. A simple bit of energy accounting takes care of this whole thing. I would like for all of you now to use the work energy theorem to solve this problem. You have 60 seconds. that's the right number.
8.3.
8.3. It's a simple matter of just accounting for the total work done on him. Gravity is doing mgh worth of work as it comes down, positive or negative. Is it speeding him up or slowing him down? Speeding him up, so it's positive work. And the jetpack is doing negative work on him. Take that away, set that equal to the change in kinetic energy, and we are done.
I think the wording of the problem says the forces of gravity is what set many people up to use the sum of forces.
Yeah.
They didn't think to use work because it's the forces in the problem.
That makes, I understand what you're saying here. I think there's something to be learned, and that is that forces do work. And when we talk about potential energy, for example, we're talking about potential energy that a force stores up. And so I can see why your initial thought might be, let's do sum of forces. But as soon as you do that, I think you would realize, hey, wait a second, I don't really have the ability to do sum of forces because my jetpack force is all over the place. It's not a constant force that I can work with. Now, a couple of people cleverly, you might have been one of these, figured out the average force.
Yeah, I actually asked a question on that.
Yeah.
Attention for more after the announcements.
All right, we'll call it a day.
Outside.
I'll see you tomorrow.